There's a strip of material thinner than a pencil that increases your wall insulation by 70%. Not by adding more fiberglass, not by tearing out your walls and starting over. One application, permanent. SpaceX uses this exact material on Starship. NASA's Kennedy Space Center developed it in 1992 to protect rocket fuel lines colder than outer space. Every wood-framed house in America has the flaw this fixes. And somehow, after 30 years, it's still not in your walls. Then someone did the math. The insulation industry generates $12.5 billion a year. The HVAC industry generates over $130 billion a year. Those numbers depend on a very specific math problem remaining unsolved. That problem is thermal bridging. The knowledge existed, the product was manufactured, and then it simply stopped. This is the story of aerogel, the material NASA trusted to protect rockets, the material the building industry kept off your walls for 30 years. In 1992, James Fesmeyer was a senior principal investigator at NASA Kennedy Space Center's Cryogenics Test Laboratory. His job was simple and impossible at the same time. He needed to insulate liquid hydrogen fuel lines for the space shuttle. Liquid hydrogen is 423 degrees below 0 Fahrenheit. It is cold enough to turn oxygen into a liquid, cold enough to shatter steel. Traditional insulation could not survive it. The material failed. It cracked. It degraded. And the heat that should not have gotten through always did. Fesmeyer needed something revolutionary, not just better insulation. Insulation that was ultra-thin and ultra-effective at the same time. Kennedy Space Center awarded Aspen Systems Inc. Small Business Innovation Research contracts to develop flexible aerogel composites. The work took years. Failed prototypes accumulated. But by 1993, the first aerogel composite blankets were created, cookie-sized lab specimens that performed like nothing the team had ever tested before. By 1994, Fesmeyer invented the Cryostat 1, a specialized instrument designed to measure aerogel's thermal performance under the extreme conditions of space. The data confirmed what theory suggested. This material was extraordinary. In 1996, aerogel composites were launched on the X-33, an experimental launch vehicle. By 2003, Aspen Aerogels and Kennedy Space Center jointly received an R&D 100 award. In 2004, commercial production began. The breakthrough had moved from the laboratory to the real world. But what exactly is aerogel? Imagine taking a solid material and removing 99.8% of the mass and replacing it with air. What remains is a structure of silicon dioxide, a silica skeleton, suspended in nothing but empty space. It looks like frozen smoke. It is the lightest solid material on Earth. It holds 16 Guinness World Records, including the title of Best Insulator. Fiberglass insulation achieves an R value of 3.5 per inch. Aerogel achieves an R value of 10.3 per inch, nearly 3 times better, and it is mostly air. The SpaceX connection is direct. Aerogel has been tested on the International Space Station through SpaceX Dragon resupply missions on Mississippi 9, Mississippi 12, and Mississippi 15. The same thermal engineering principles that protect Starship's cryogenic fuel systems are the same principles that could protect your home. They always were. Now consider your walls. Picture a standard 2x4 wooden stud frame with studs spaced every 16 inches. Do the math. 25% of your exterior wall is solid wood, and 75% is the space between the studs where your fiberglass insulation sits. But wood conducts heat, and fiberglass resists it. Heat always takes the path of least resistance. It travels straight through the studs, completely bypassing 100% of your cavity insulation. This is thermal bridging. Your studs are heat highways running directly from the outside air to the inside of your home. Oak Ridge National Laboratory measured this phenomenon. A wall rated R value 19, when tested in real conditions with real studs, performed at R value 12.8. That is a 33% loss in actual performance. In poorly installed walls, the loss climbed to 42%. The problem was not theory, it was measured, documented, and published in peer-reviewed literature. 35% of a home's total energy loss occurs through exterior walls. That is more than windows, doors, or the roof. In some wall assemblies, Oak Ridge found that 78% of heat loss traveled through thermal bridges alone. 78%. The insulation between the studs was nearly irrelevant to the overall performance of the wall. The studs themselves were the dominant factor. Aerogel strips create a thermal break at every stud edge. A quarter-inch thick aerogel strip achieves an R value of 2.5 at the thermal bridge point. That single quarter-inch addition increases the R value of the entire wall by 32 to 40%. It solves a problem that fiberglass alone cannot. The science was published, the product was manufactured, and then it simply vanished from public awareness. The insulation industry operates on a simple economic model: fiberglass, mineral wool, cellulose. These materials degrade over time. They settle, they compress, they lose effectiveness, they need replacement. The industry sells insulation by the truckload. It profits from repeat replacement cycles. The HVAC industry profits from maximum air conditioning runtime. Summer temperatures push homes toward 95 degrees because the walls leak heat in winter and summer both. That leak is a feature of the business model, not a bug to be eliminated. Building codes ignored thermal bridging for 100 years. The problem was too foundational, too widespread, too economically disruptive to fix retroactively. ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, finally addressed thermal bridging in its standard 90.1, the 2022 edition. 100 years after the first wood frame houses were built, 30 years after NASA solved the problem for rocket fuel lines. The standard R value labels on insulation hide the truth. They measure performance between the studs, not including the studs. A wall labeled R19 displays only the cavity insulation's performance. The label does not say that real-world R value drops by a third or more because studs conduct heat. That is like advertising a water bucket's capacity while ignoring the holes in the bottom. Contractors trained before 2020 rarely know about thermal bridging. It was not in their textbooks, it was not in building codes, it was not on job sites. Thermobloque, the commercial aerogel strip product, is available, but not at Home Depot. Not at Lowe's. Special order only. No consumer advertising. No presence in mainstream building supply retail. Aspen Aerogels manufactures 20 million square feet annually. The company focuses on industrial applications and commercial construction. Residential contractors and homeowners exist outside their primary marketing. The knowledge exists in archived studies from Oak Ridge, in NASA technical papers, in ASHRAE standards, and in peer-reviewed journals. But that knowledge never reached the people living in wood frame houses. It never penetrated the homeowner market. It never disrupted the trillion-dollar energy consumption cycle that depends on inefficient walls. A homeowner in North Carolina decided to address this during a renovation. They ordered Thermoblock aerogel strips online. The material arrived in rolls with the adhesive backing ready. Before drywall installation, they peeled the adhesive and pressed the strips onto the edge of every exterior stud. The material cuts easily with a utility knife. They wore a dust mask. Aerogel is mostly air, and the manufacturing process creates fine particulates. Careful handling and respiratory protection are standard. The material cost approximately $2 to $6 per linear foot of stud edge. For the perimeter of a 1,500 square foot home, the total material expense came to $800 to $1,200. The installation required 1 extra day of labor. An energy audit performed before the renovation showed the wall assembly performing at an effective R value of 11. After installation, that same wall assembly measured an R value of 15.4. That is a 40% improvement from a quarter-inch strip. The first winter's heating bill dropped 22%. The first summer's air conditioning bill declined similarly. A contractor had quoted $3,500 to add an additional layer of fiberglass insulation everywhere. The aerogel strips achieved better results for $1,100. The approach works best during new construction or major renovation when studs are still exposed. Retrofit application on existing walls requires removing drywall, which creates expenses that make the project economically marginal unless other work justifies the disruption. The material costs more than fiberglass per square foot. Fiberglass runs 50 cents to $1.50 per square foot. Aerogel strips cost $2 to $6 per linear foot. The dust requires respiratory protection and gloves during application. The product works in all climates, unlike radiant barriers, which depend on sun exposure and provide only seasonal benefit. Aerogel works year-round, winter and summer, in every geography. It is not a replacement for cavity insulation. It is a complement. The fiberglass and the aerogel work together. One addresses the cavity, the other addresses the bridge. Together, they solve a problem that neither could address alone. Flashback to 1992. James Fesmeyer at Kennedy Space Center staring at the problem of insulating liquid hydrogen. The breakthrough that followed protected rockets. The principle remains unchanged. A thermal break, an interruption of the heat pathway. Whether the pathway is a fuel line or a wooden stud, the physics is identical. Every wood-framed house built in the last century has thermal bridges. Billions of homes. Billions of studs. The studs holding your walls together are the same studs bleeding your heating and cooling budget into the outdoor air. Oak Ridge measured it. Kennedy Space Center solved it. ASHRAE finally acknowledged it in 2022. 100 years of housing construction with a known and fixable flaw. That's not oversight, that's architecture. Your grandfather's house had this flaw. Your house has this flaw. Your children's house will have this flaw unless someone fixes it. Unless someone applies a quarter-inch strip of frozen smoke to every stud edge before drywall goes up. Unless someone breaks the economic dependence on inefficiency. $12.5 billion in the insulation industry. $130 billion in the HVAC industry. $3.5 trillion in annual U.S. energy consumption. Those numbers depend on a very specific arrangement. They depend on the material that NASA entrusted to protect rockets never reaching the walls of ordinary homes. They depend on you never learning that a quarter-inch strip of aerogel could change the equation permanently. Imagine the implications if every new construction project included aerogel thermal breaks. If every renovation made the choice to address studs as well as cavities. Heating and cooling demand would decline across the nation's housing stock. But demand decline disrupts an industry arranged around the opposite assumption. An assumption built on walls that leak. On HVAC systems that run continuously. On replacement cycles measured in decades instead of a single application that lasts the life of the building. The material sits on the stud edge, invisible behind the drywall. It will never degrade. It will never settle or compress. It will do what fiberglass never could. It will stop heat at the one place it was always getting through. And the wall will perform as the labels claimed all along.